Okay, now let's move on to the next slide. The glomerulotubular balance between the glomerulus and tubulus. Now this balance. Now an intrinsic ability of our kidney, of our tubules, is that it is simple. If there is more pressure, if the GFR rate is increasing, if the arterial pressure is increasing, if the filtration has increased, I will increase the reabsorption rate. Simple. The more the pressure, the more the filtration, the more the reabsorption. Simple words. So that's the glomerulotubular balance. The glomerulotubular balance. So it will say that it is an intrinsic ability of the tubules to raise their rate of reabsorption in reaction to the increasing tubular filtration. So if the tubular filtration rate is increasing, tubules are saying I am going to increase the rate of reabsorption. So balancing that. And this is also done by means of neural, hormonal and other mechanism. Now finally the pressure diuresis. Here the pressure is going to act on the regulation. How? In a phenomena, if there is an increase in the arterial pressure in the arterioles, if the pressure is going to increase, now it causes an increase in the urinary excretion of sodium and water. Our last slide. When the pressure and blood volume increases, there will be release of ANP, the atrial natriuretic peptide. And what it will do? It will cause increase in the sodium and water in the urine. So sodium and water will be excreted in the urine. So when it will be excreted in urine, the pressure will come down, the pressure balance. If the arterial pressure increases, there will be excretion of more sodium and water in the urine, the pressure increases. The balance between both. That was related to this. Now, finally, let's move on to the role of kidney in regulation of the osmolarity and the volume. And this is done. What is osmolarity? Osmolarity is basically the concentration of the solute particles inside a 1 liter of solvent. That is the osmolarity. So how the kidney maintains the osmolarity and the volume in our body, especially in the blood. So you can see from here, it all states there are two conditions. So in case of hyperhydration and in case of dehydration. In dehydration, we already came to know how it will do. Now finally, in case of hyperhydration, when you are ingesting more water than normal, so there is a water ingestion, you are drinking too much water inside, what will happen? The extracellular fluid, the extracellular level of water will also increase because of that. Now, when this increases, the blood volume will increase. So, blood volume is going to increase. Now, what happens when your blood volume, our previous last slide, when the blood volume increases, last time we see that there was, whenever the blood volume decreases, there will be release of some hormones. Now, the blood volume has increased. The point is that it increased because of too much water ingestion. So, our blood volume, there are receptors, the osmoreceptors. The osmoreceptors are going to send the stimulus that here is too much water in the blood volume is very much increased. So it will go senses to our hypothalamus, the thirst center of our body. The hypothalamus is going to say one thing. No, it will send the sensation, don't drink too much water. Already you are full. First. Second, it is going to decrease the release of ADH. We know the role of ADH, antidiuretic hormone. Antidiuretic hormone is going to increase, it is going to reabsorb more water. But already our water level is more, so we don't need it. So there will be decrease in the secretion of ADH. When ADH will be decreasing, the reabsorption of water will decrease. The reabsorption of water will decrease from the kidney and more water will be excreted. So that is the whole scenario how it happens. How the osmolarity of the blood volume is maintained. You got it? That is the whole scenario of it. Finally, let us move on to our last slide. That is the regulation of renal function by the hormones. Already we have seen this in the whole scenario of our last slide. Now let me tell you a brief about this. The first one was the antidiuretic hormone, the ADH. Why is it called the antidiuretic hormone? Because anti means something which is against. And diuretic hormone, diuresis. The diuresis is when there is an increase in the urine output. Diuresis. So it is against the urine output. It decreases the urine output. So that is the antidiuretic hormone, which is secreted by the posterior pituitary gland. Posterior pituitary gland. Okay, and it attacks on it has its action on the distal, and it acts on the collecting duct and collecting tubule, and it causes water reabsorption. So this is the antidiuretic hormone. Next is the atrial natriuretic peptide, or also called as the atrial natriuretic factor. It is released by the atrium, left atrium, and it acts on the renal tubules, and it's very important, excretion of sodium and water from the tubules. It increases the excretion of sodium and water from the tubules. So that is our atrial natriuretic peptide. Because of that, there will be decrease in the reduced blood pressure and blood volume. Next is the aldosterone. The aldosterone, already we know, when the angiotensin II knocks the door of adrenal gland, aldosterone will be released. Now this aldosterone is going to act on the renal tubules, on the distal convoluted tubule, and it causes a reabsorption of sodium. More the sodium will come in, more water will come along with that, and blood volume, blood pressure will increase. Aldosterone. And finally is the angiotensin, the hormone which is being inactive form, that is the angiotensinogen, which is being converted by the renin into angiotensin 1. And this angiotensin 1 is very weak. It don't have that much energy, not potential to change the problem, to change the cause. So it will be converted into the angiotensin 2 by the lungs. Now this angiotensin 2 is very active. It has the potential, it's energetic, and it is going to knock the door of aldosterone. It is going to knock the door of hypothalamus to release ADH. So that whole scenario we already know, then it will regulate the balance. So these were the 4 important hormones in role they play, that plays a role in our regulation of the renal function. So this was our last topic related to our renal system. With this, we have ended our renal system. So see you in the next video with some interesting unit of our anatomy and physiology. Until that, goodbye. Thank you.